100 sorties a day, 2 nuclear hearts, electromagnetic catapults capable of launching hellfire in seconds. That was the steel roof of the USS Gerald R. Ford, a $13 billion statement of absolute mathematical dominance. But in the shark-infested waters of the Strait of Hormuz, that math just hit zero. A single spark in a laundry room did what 40 years of Iranian threats couldn't. It forced the most advanced warship in human history to limp away. The shield was gone. Iran calculated the hunt was finally on. But here is the real mystery. Why did the Pentagon smile while their crown jewel was burning? There is a secret hidden in the logistics of the strait that Iran never saw coming. And it's the only reason a total disaster turned into a masterclass in modern warfare. Stay with me until the very end, because I'm going to show you the exact moment the hunter became the prey, and how a laundry fire accidentally rewrote the rules of the sea forever. Let's draw the line in the sand. To understand the devastating silence after Ford departed, we must first understand the absolute, uncompromising challenge behind its creation. For half a century, the Nimitz class was the undisputed king of the horizon. But as the 21st century began, the Navy realized that good enough was a death sentence. They didn't need an evolution. They needed a revolution. They needed a ship that didn't just carry an air force, it was the Air Force. And the USS Gerald R. Ford is not merely an evolution of the Nimitz class. It represents a fundamental structural rejection of the mechanical limitations that once defined 20th century naval warfare. The Ford was designed to solve a single, unprecedented problem in history: how to launch more aircraft, faster, with fewer personnel, and sustain that pace longer than any naval platform before it. At the Newport News shipyards, this was achieved through a series of superlifts, massive prefabricated sections weighing up to 1,050 tons, assembled by the Big Blue crane with absolute precision, allowing an extraordinary density of technology to be integrated within the ship's 17-deck hull. It is 4.5 acres of sovereign American territory, moving at 35 knots. This modular shipbuilding philosophy enabled the seamless integration of more than 3 million meters of electrical cable, transforming the aircraft carrier from a traditional vessel into a nuclear-powered, sovereign mobile city. The foundational miracle of the Ford is its power plant, the Bechtel A-1B nuclear reactors. In the legacy fleet, power was a zero-sum game. Every kilowatt used for the radar was a kilowatt taken away from the catapults or the propulsion system. Traditional diesel or even older nuclear designs were logistical shackles that limited the energy available for the high-intensity sensors and weaponry required for modern conflict. The Ford breaks these chains with 2 A-1B reactors that produce 3 times the electrical load of the Nimitz class, surging with 13,800 volts of raw, unadulterated amperage. This is not just about moving a hull at 35 knots. It is about the electrical ship philosophy. This immense power reservoir enables the transition from legacy mechanical systems to a fully digital environment. These reactors use nuclear fission to generate intense thermal energy, converting water into high-pressure steam to drive the propeller shafts, but their true genius lies in their endurance. They are designed to operate for 25 years without a single refueling. This creates an unparalleled operational window, as demonstrated by the Ford's 261-day continuous deployment. This abundance of power provides the technical headroom for future integration of directed energy weapons and advanced sensor suites that have not even been invented yet, ensuring the ship remains the pinnacle of naval warfare for its 50-year lifespan. On the flight deck, the most visible revolution is the death of the steam catapult. For 60 years, steam was the violent, corrosive master of naval aviation, a dumb system that hit every aircraft with the same brutal hammer blow of pressure, regardless of its weight. The Ford replaces this with EMALS, the Electromagnetic Aircraft Launch System. EMALS utilizes the ship's massive electrical reserves to create a traveling magnetic wave. Beneath the 300-foot launch rails, a series of electromagnets are energized in a sophisticated, computer-controlled sequence. This allows for a degree of acceleration precision that was previously impossible. EMALS can accelerate a 50,000-pound F-35C to 150 miles per hour in under 3 seconds, or it can dial back the power to gently launch a lightweight, fragile, unmanned drone without compromising its structural integrity. By removing the moisture, heat, and high-maintenance requirements of steam troughs, EMALS reduces airframe stress and slashes the manpower needed for maintenance, allowing the Ford to sustain a punishing launch rhythm that would literally rip older carriers apart. Launching a jet, however, is only half the engineering challenge. Bringing it back safely is a life-or-death calculation governed by the Advanced Arresting Gear, or AAG. The Ford utilizes the AAG to stop a 22-ton aircraft traveling at 150 miles per hour in just 350 feet, a mere fraction of a land-based runway. The AAG is an evolution of the sandbag and rope concept pioneered in 1911, but updated with 21st century robotics and energy recovery systems. As the aircraft's tailhook snags the deck pendant, the kinetic energy is transferred to a water twister, a large paddle wheel submerged in fluid located beneath the flight deck. This water twister absorbs 2/3 of the landing energy through frictional resistance, while the remaining energy is managed by a motor generator that converts the mechanical pull into electricity for future use. Controlled by sophisticated software, the AAG actively adjusts the cable tension every millisecond of the 2-second landing, compensating for off-center approaches and protecting the aircraft from the structural fatigue that plagued older hydraulic arresting systems. The most radical change to the Ford's silhouette is the relocation and shrinking of the island. By pushing the command tower further toward the stern, engineers unlocked 5 acres of prime flight deck real estate. This created a centralized pit stop area where aircraft can be rearmed and refueled in a single location rather than being moved across the deck multiple times in a dangerous and time-consuming shuffle. This layout, combined with the angled flight deck, creates a living airport capable of simultaneous launch and recovery operations. By deconflicting these flight paths, the Ford achieves a sortie generation rate that is 25% higher than its predecessors, allowing for over 200 missions a day. The inclusion of electromechanical elevators on the ship's perimeter ensures that aircraft and munitions can be brought up from the hangar without ever disrupting the lethal ballet occurring on the deck. Every weld and every meter of cabling was designed for the high-stakes environment of places like the Strait of Hormuz. Yet, engineering truth also demands an acknowledgement of vulnerability. A machine that runs for 261 days without a port call, carrying 4,500 people and maintaining 75 aircraft, will eventually find its limit. The fire in the laundry room was a reminder that even a $13 billion Titan is bound by the laws of thermodynamics and the friction of time. However, because the Ford is an electrical ship, its ability to recover and reintegrate its systems is far superior to any legacy hull. It defines industrial depth, the ability of a superpower to engineer a crisis into a configuration of even greater lethality, proving that the Ford is the most adaptable and technologically dense weapon system ever to sail the world's oceans. When the USS Gerald R. Ford turned its bow away from the Red Sea, it didn't just leave a gap in a naval formation. It triggered a geopolitical eclipse. To understand why this silence is so catastrophic, you have to understand the rigid, unforgiving mathematics of the United States Navy. We operate 11 nuclear-powered supercarriers, the largest and most lethal fleet of capital warships in human history. And yet, in the spring of 2026, 11 is not enough. The Ford's fire exposed a structural vulnerability that no amount of money can fix on a moment's notice. It revealed a zero-sum reality of global power projection. The Lincoln was committed to the Arabian Sea. The Truman was entering a grueling 4.5-year nuclear refueling overhaul, a process that literalizes the word immobile. The Eisenhower had just returned from a record-breaking deployment, its crew exhausted and its machinery pushed to the absolute breaking point. Carrier availability is at its tightest in a generation, with nearly half the hulls unavailable at any given time due to maintenance or training cycles. There was no other queen to move across the maritime chessboard. When the Ford left, the steel roof didn't just leak, it vanished. In Tehran, the leadership didn't see a mechanical failure. They saw a prophecy fulfilled. For 40 years, the Islamic Revolutionary Guard Corps, IRGC, has prepared for this exact window of opportunity. They built their entire national identity and military doctrine on the belief that they could choke off the world's lifeline if the American giant so much as blinked. They believe that their moat of thousands of pressure-activated mines and their hidden coastal missile batteries are the ultimate equalizer against $13 billion warships. To Iran, the departure of the Ford was the signal to execute a plan 4 decades in the making. But to understand why they are willing to gamble everything on this narrow stretch of water, you must grasp the staggering, terrifying weight that the Strait of Hormuz carries in the global economic cycle. The economic importance of the Strait of Hormuz stems from its role as the primary, and in many cases, the sole export route for the world's largest oil and gas fields. This is the jugular of modern civilization. Countries such as Iraq, Kuwait, and Qatar depend on this needle-thin passage for their very survival. In 2025 alone, roughly 15 million barrels per day of crude oil and 5 million barrels per day of refined petroleum products surged through this route. Look at the flow. Nearly 90% of the crude oil transiting this strait is destined for Asian refineries. China and India alone receive more than 40% of this volume. Japan and South Korea source approximately 95 and 75% of their crude oil needs from this region, respectively. Even the United States, despite massive increases in domestic production, continues to rely on the strait for about 7% of its total oil consumption. But if you think this is only about the gasoline in your car, you are missing the most dangerous variable: liquefied natural gas, LNG. In 2025, over 112 billion cubic meters of LNG, equivalent to roughly 20% of total global LNG trade, were transported via this passage. Qatar, the world's second-largest LNG exporter, depends entirely on this route for all its maritime shipments. Disruption in LNG flows is a threat far more severe than oil. Why? Because while oil can be diverted or stored, the large-scale alternative infrastructure for natural gas transport is almost non-existent. There are no spare pipelines waiting to replace the volume of the strait. If the gas stops, the lights don't just flicker, they go out. Beyond energy, the Strait of Hormuz plays a decisive, yet often invisible role in the global macroeconomic cycle. Consider the industrial metal markets. Aluminium production in Gulf countries reached approximately 6.3 million tons in 2024, accounting for 9% of global output and nearly 23% of the global supply outside of China. Currently, the aluminium market faces a structural deficit of 600,000 tons. Any disruption in the strait would trigger a price spike on the London Metal Exchange, LME, that would send aluminium soaring past $3,400 per ton, with potential surges to $4,000. This would paralyze industries from aerospace to automotive manufacturing across Western Europe and North America. Then there is sulfur, the invisible commodity of the global economy. Due to extensive natural gas sweetening and sour crude refining, the Gulf region produces roughly 44% of the world's sulfur. This is the lifeblood of the chemical fertilizer industry, which accounts for 70% of global sulfur demand. If supply disruptions continue for more than 2 months, the production of strategic crops such as corn, soybeans, and wheat would collapse. We are talking about a direct threat to global food security. Furthermore, modern extraction processes for critical metals like nickel, cobalt, and copper, the building blocks of the green revolution and electric vehicles, rely heavily on sulfuric acid. Nickel production in Indonesia and copper in Central Africa are physically dependent on the sulfur flowing through the Strait of Hormuz. If you choke the strait, you choke the future of renewable energy. The ripple effects extend even into the high-tech heart of the 21st century. The global semiconductor and electronic sectors require substantial quantities of high-purity sulfuric acid for microchip production and silicon wafer processing. Any shortage would skyrocket manufacturing costs in East Asian tech hubs like Taiwan and South Korea. But there is a deeper link. Many semiconductor manufacturers rely on Qatari LNG for stable electricity. Taiwan, for instance, sources roughly 30% of its LNG through the Strait of Hormuz. In such a scenario, even a limited disruption could affect companies like TSMC, which produces nearly 90% of the world's most advanced chips and consumes approximately 9% of Taiwan's total electricity. If the strait goes dark, the digital world stops. Your smartphone, your medical equipment, your defense systems, all of them are tethered to the security of this waterway. Tehran knows these numbers. They have warned that any military adventurism in the region could have irreversible consequences, placing the responsibility squarely on the United States. They believe they hold the world hostage. They believe that without the USS Ford and its steel roof, the American giant is blind and toothless in the face of their minefields. They operate on the logic of an eye for an eye, thinking that by blinding the global economy, they can force a superpower to retreat. They saw the Ford limp away, and they recalculated. They saw a $13 billion void and believed they had finally found the variable that would break the American equation. To Iran, the strait is a moat, and their minds are an untouchable wall. They prepared for a war of attrition against a carrier that was no longer there. But as the world watched the Ford withdraw, they failed to see the accidental juggernaut forming on the horizon. Chaos theory suggests that small changes in initial conditions can lead to vast differences in outcomes. Iran calculated for a world without a carrier. They did not calculate for a world where the US Navy reconfigures itself into a force far more visceral and adaptable than a single supercarrier. While Tehran celebrated the departure of the nuclear titan, they didn't hear the roar of the hovercraft engines. They didn't hear the boots of 4,400 Marines who were about to prove that a moat is only a moat if you can't fly over it. The void left by the Ford was about to be filled by a sledgehammer. As Gandhi famously said, "An eye for an eye makes the whole world blind." Iran wanted to blind the world to win the Strait. They never realized that the Americans were about to change the way the world sees a naval battle. My dear friends, now let us return to the original question we raised. The fire on the most expensive carrier in history just changed the balance of power at the Strait of Hormuz. When the USS Gerald R. Ford, $13 billion of nuclear-powered defiance, was forced to withdraw to Suda Bay for repairs, the Pentagon's response was not another carrier. It was something far more visceral, far more grounded, and infinitely more dangerous to the entrenched defenses of the Iranian coastline. It was 4,400 Marines and a radical reconfiguration of naval power that Iran never prepared to counter. This was not a retreat. It was an evolution. 7 days after the blaze on March 12th, the Pentagon pulled the USS Boxer LHD-4 forward by 3 weeks to join the USS Tripoli LHA-7. This maneuver changed the math of the Strait, and that math demanded an answer the carrier fleet simply could not provide. To understand why this reconfigured force is a nightmare for Tehran, one must grasp the fundamental difference between a super carrier and an amphibious assault ship. If the USS Ford is a scalpel, a high-tech precision instrument designed to strike from the stratosphere, then the combination of Tripoli and Boxer is a sledgehammer. The Ford is a steel roof, a majestic shield that dominates the sky, but the Tripoli and Boxer are the walls and the floor. For 40 years, Iran fortified the shipping corridor, turning the islands of Abu Musa, Greater Tunb, and Lesser Tunb into unsinkable weapon platforms. They spent decades laying a moat of thousands of pressure-activated mines, believing this made their shores untouchable. They calculated for a navy that fights only from the sky. They never calculated for a force that rides over the very mines meant to protect them. Look at the architectural philosophy of these two ships. The USS Tripoli is Flight Zero of the America class, the Navy's bold experiment in building a pocket carrier. To double her hangar space for 20 F-35B stealth fighters, she deliberately abandoned her well deck. Tripoli is a sports car, fast, agile, with an enormous range, but she has no trunk. She solves half the problem by providing the roof, the air cover, but she cannot put boots, tanks, or heavy artillery on a hostile shore. She is a sky warrior, a platform for the stratospheric reach of the F-35B. The USS Boxer, a Wasp-class veteran, represents the opposite philosophy. She is the pickup truck of the fleet. She is slower, older, and perhaps less sleek, but she carries everything you need to build a permanent foundation once you arrive. Unlike Tripoli, Boxer kept her well deck, a massive 266-foot-long, 50-foot-wide flooding bay that opens at the stern to the ocean. While Tripoli carries 20 F-35Bs and fights from the clouds, Boxer carries the landing craft, the armored assault vehicles, and the Marines trained to put all of it on a hostile beach. Individually, these ships are incomplete. Tripoli has the eyes and the reach, but no hands. Boxer has the muscle and the tools, but limited eyes. Together, they solve the entire equation. The fire on the Ford accidentally forced the U.S. Navy to create the most powerful amphibious force the Strait of Hormuz has ever seen, a force that combines high-altitude stealth with low-altitude brute force. This is where the engineering changes the very physics of the battle. Iran's 3 fortified islands were seized in 1971 and have been transformed over 5 decades into IRGC garrisons bristling with anti-ship missile batteries, radar arrays, and artillery. They believed the water around them was an impassable moat because of the minefields. But the Boxer carries the final variable in this lethal equation, the LCAC, landing craft air cushion. Here is the engineering reality that makes the assault possible. A conventional landing craft is a displacement hull. It sits in the water. To trigger a pressure-activated mine, you need concentrated hull contact, but an LCAC does not float. It flies. It hovers 7 feet above the water on a pressurized cushion of air. Because the LCAC never touches the water, it cannot trigger the mines Iran spent 40 years laying. Where every conventional vessel in the fleet, including the Ford, cannot go, the LCAC flies through. Run the math. A conventional landing craft makes 10 knots through mined water. To cross 5 nautical miles of minefields, it faces 30 minutes of lethal exposure to coastal batteries while moving at a snail's pace. An LCAC crosses the same distance at over 40 knots. That is 7.5 minutes of hovering safely above the mines. It isn't just a boat. It is a high-speed delivery system for M1 Abrams main battle tanks and heavy weapons. The strategy that emerged from the Ford's fire is a lethal interlocking cycle. It begins with Tripoli executing vertical envelopment. MV-22 Ospreys and CH-53 helicopters fly over the minefields, never touching the water. They land marine strike teams on the high ground of the islands to neutralize radar installations and missile launchers. But these light units carry only personal weapons. They can raid, but they cannot hold. This is where Boxer completes the equation. Her well deck opens and the LCACs launch, delivering the heavy armor, the tanks, and armored vehicles directly onto the beach. Iran is suddenly forced to defend from the top and the bottom at the exact same time. Heliborne Marines on the ridgeline, Abrams tanks on the shoreline. This is no longer a raid. It is a full amphibious seizure. While 2,200 Marines could strike and withdraw, 4,400 Marines arrived to stay. They seized the territory, neutralized the threat, and turned the islands into American fire bases. Seizing an island takes a day. Holding an island takes weeks. This is where the logistics of the pickup truck outshine the supercar. Marines on shore need ammunition, fuel, food, and spare parts continuously. This is the core of EABO, Expeditionary Advanced Base Operations. This doctrine allows Marines to establish HIMARS rocket launchers and forward arming points on small islands to control the strait with shore-based firepower. The question is resupply. Tripoli can resupply by air, but an MV-22 Osprey at the combat ranges required for Hormuz resupply carries an effective payload of only 8,000 pounds. That is enough for food and medical supplies, but it cannot sustain heavy combat. It cannot deliver bulk fuel, armored vehicles, or the heavy reload pallets for HIMARS. The Boxer's LCACs changed the logistics math entirely. One LCAC carries over 60 tons, 120,000 pounds per trip. Run the numbers. One LCAC trip equals 15 Osprey sorties. Boxer carries 3 LCACs. With 3 trips per day per craft, that is 9 LCAC runs, delivering 540 tons of supplies daily. To match that by air alone, Tripoli would need to fly 135 Osprey sorties every 24 hours. The airframes cannot sustain that rate. Without the well deck, EABO is just a concept. With the well deck, EABO is a permanent fire base. Marines don't just fly in and shoot, they arrive, establish, and stay. Finally, there is the problem of the minesweepers. The Navy's LCS mine countermeasure ships use advanced lasers and sonar drones to clear the shipping lanes, but the ships themselves are slow, fragile targets. They face two threats: Iranian surveillance drones from above and IRGC fast attack craft from the surface. Tripoli provides the roof. F-35Bs on combat air patrol detect surveillance drones and kill them before they can transmit coordinates to coastal missile launchers. If the drone dies, the kill chain is broken and the missile never fires. But Tripoli cannot be everywhere, and she carries no surface craft to protect the sweepers from the hundreds of Iranian fast boats hidden in coastal inlets. Boxer provides the walls. Her well deck deploys rigid hull inflatable boats and patrol craft to establish a surface screen around the minesweepers. Simultaneously, AH-1Z Viper attack helicopters from her deck fly low-altitude patrols, hunting fast boats with Hellfire missiles before they ever reach engagement distance. For the first time at Hormuz, mine clearance operations have a full 360-degree protective bubble, air cover from above and surface defense around the perimeter. The timeline for clearing the shipping corridor compresses from months to weeks. The fire on a $13 billion carrier may have removed a queen from the board, but it accidentally triggered a checkmate. The Marines didn't just arrive to fight, they arrived to own the strait. This is the accidental advantage. This is how 2 ships and 1 fire changed everything at the Strait of Hormuz. My dear friends, what we have witnessed at the Strait of Hormuz is the ultimate paradox of modern power. We spent this journey marveling at the USS Gerald R. Ford, a $13 billion titan of nuclear and electromagnetic genius. It is easy to be blinded by such technology, to believe that steel and circuits alone win wars. But the fire on March 12th stripped away that illusion. It taught us that in the world of high-stakes maritime strategy, the most expensive tool is not always the most effective one when the environment changes. The Ford was the peak of engineering, but the Navy's response was the peak of adaptability. This is the true industrial depth of a superpower. It is the ability to lose a crown jewel and, instead of retreating, reconfiguring the entire board into something even more visceral. We admire the Ford for the science of its reactors, but we must reserve our deepest respect for the sailors and Marines who turned a mechanical disaster into a tactical masterclass. They proved that while technology has its limits, found at exactly 261 days of exhaustion, human ingenuity and flexibility do not. The Strait of Hormuz remains the world's most volatile Kuang-hong, but the steel roof has been replaced by something far more persistent, a permanent interlocking web of amphibious firepower. This wasn't just about clearing mines, it was about demonstrating that a moat is only an obstacle if your mind is anchored to the sea. The Marines didn't just break the siege, they broke the very logic Iran used to build it. As we look to the future of naval warfare, let this be the lasting image: a nuclear titan retreating into the mist and a swarm of hovercraft rising from the surf to take its place. Iran spent 4 decades preparing to defeat a ship, only to be utterly subverted by a configuration they never trained to face. They were ready for the giant, but they were conquered by the soldiers who ride on air. The Titan may have rested, but the mission never wavered. And that, more than any machine, is why the balance of power remains exactly where it belongs. Finally, before I leave you today, thank you for standing with me on this journey. This analysis of the 261-day marathon of the USS Ford and the 4,400 Marines who filled the void at Hormuz represents my personal perspective on this unfolding maritime drama. Every machine has a limit, and every crisis has a strategy. If you have your own stories or insights about this naval tragedy, or if you've witnessed the grit of these sailors firsthand, please share them in the comments below. Your voice adds a new layer to this deep blue mystery. If this deep dive resonated with you, I invite you to like, share, and subscribe to join our growing community of maritime explorers. Until our next voyage into the unknown, stay sharp, and I'll see you in the next breakdown.